Hi all, this is Dr. K. Lekha, Assistant Professor, Department of ECE from SRM Valliyamma Engineering College. So today we are going to see about line coding techniques in digital communication. So this is the outline of today's lecture. Uh, so moving on, why we need line coding? So it is the other way from computer. So when information is transmitted, they will be discrete in nature. So when they are transmitted over a band limited channel, there are high chances of signal getting dispersed. So which causes overlap and distortion. The distortion is in the means of interference called inter-symbol interference. The inter-symbol interference, the name says that there is an interference between the successive symbols or informations. Okay, so what is line coding? So line coding is a technique which converts the binary data, that is zeros and ones, to a sequence of pulses. Okay, so this is called line coding. Moving on to the properties of line coding, the transmission bandwidth of line coding will be small as possible, and power efficiency will be also as small for given bandwidth and the probability of error. It has high error detection and correction capability with favorable spectral density. So we have adequate time content. We can extract timing from the pulses, and for preventing the long strings of zeros and ones, the line coding will help us. So there are three basic type of line coding techniques. They are unipolar, polar and bipolar. Okay. So when moving on to the unipolar type, it is an on-off keying. That is, when you transmit binary 0, there will be absence of pulse, and when you transmit 1, there will be presence of pulse. In unipolar, there are two types which are non-return to 0 and return to 0. In unipolar non-return to 0, as you can see that when a binary bit 1 is transmitted, you have presence of pulse, and when you transmit binary bit 0, there will be absence of pulse. Okay, so this is the time duration. The time duration or bit duration of the single bit is called T0, or it can be said as TB. Okay, this is unipolar non-return to 0. So moving on to the unipolar return to 0. Okay, contrast to non-return to 0, in return to 0 type, for bit 1 transmission you will have pulse, and for bit 0 you have no pulse. But within the off bit duration, that is within the TB or T0, off of TB or T0, the pulse will return to 0. As you can see in the figure, when bit 1 is transmitted, you have pulse, but at the off bit duration, it is returned to 0. Okay, so for 0, there is no pulse. And again, for when bit 1 is transmitted, you have pulse, which return to 0 at the off bit duration. So this is unipolar return to 0. Okay, so the next type is polar signaling. Similar to unipolar signaling, you have two types in polar signaling, that is return to 0 and non-return to 0. Whereas in polar type, you have two amplitude, that is positive and negative amplitude. Okay, so when bit 1 is transmitted, it will represent the positive amplitude, and when bit 0 is transmitted, it will represent the negative amplitude. As you can see, when bit 1 is transmitted, it is plus V, which is positive amplitude, and when bit 0 is transmitted, it is negative V, which is negative amplitude. And this non-return to 0, that is the within the bit duration TB or T0, the pulse will not return to 0. Whereas in polar RZ, when bit 1 is transmitted, same positive amplitude, and for bit 0 it is negative amplitude. But you can see in the figure that within the off bit duration, within off TB or off T0, the pulse is returned to 0 line. Okay, so this is the difference between polar NRZ and polar RZ. So the third type is bipolar signaling, which is called alternate mark inversion. So here we have three amplitudes or three voltage levels, plus V, 0 and minus V. So when a bit of 0 is transmitted, you have no pulse, and that is absence of pulse. And when bit 1 is transmitted, you have alternate voltage levels. It can be plus voltage plus V, or it can be minus V. The successive ones, it varies for successive ones, that for first bit of 1 you will have plus V, and the next one you will have minus V. Okay, we can see it in the example. So obviously the bipolar type also have two variations, that is NRZ and RZ, non-return to 0 and return to 0. As you can see, when a bit of 1 is transmitted, we have a pulse of positive amplitude, that is plus V, and for 0 you have no pulse transmission, that is in the 0 line. Okay, and the third bit, or that is 1, you can see that it is minus V, the negative amplitude, and for 0 again it is returning to it is no absence of pulse. Okay, so as we saw, for successive ones you have alternate voltages, that is positive amplitude and negative amplitude. Okay, and when it comes for bipolar return to 0, in bipolar return to 0, similarly you have for one positive voltage or negative, successive ones you have positive amplitude and negative amplitude alternating between the bits, and for 0 no pulse. But within the bit duration of TB, that is at off bit duration, the pulse will return to 0. Okay, so again for bipolar NRZ, for 1 you have two amplitudes, positive and negative. It depends on successive ones. Okay, for 1, as you can see in the figure, for first transmitted one you have positive amplitude, and 0 you have no pulse, and for second transmitted one you have negative amplitude. Okay, it varies for successive ones. And the last type is Manchester signaling. Here the duration of the bit is divided into two halves. Okay, when a bit 1 is transmitted, the 1 is positive in the first half cycle of the bit duration and negative in the second half. And when 0 is transmitted, it is negative in the first half and positive in the second half. As you can see in the example, when a bit of 1 is transmitted, it is positive. It has a transition from positive to negative, right? And for 0 it has a transition from negative to positive. So similarly for next one, it is moving from positive to negative, and for 0 negative to positive. So this way it moves on, and this is called Manchester signaling. So finally the comparison of line codes. When we compare the line codes with the four types, okay, that is polar RZ, polar NRZ, AMI and Manchester, the transmission of DC component is possible in polar RZ and polar NRZ, whereas it is not possible in AMI and Manchester type. And the signaling rate is same for all the type of line coding, that is 1 by TB. And as you can see, the noise immunity is high in AMI and Manchester type, whereas it is low in polar NRZ and polar RZ type. So since the noise immunity is high in AMI and Manchester, the crosstalk is low in AMI and Manchester, and it is high in polar NRZ and RZ variations. Okay, and the bandwidth required is quite low in polar RZ and AMI, and it is 1 by TB for polar RZ and Manchester, whereas the TB represent the bit duration, that is one pulse duration. Okay, so that is the TB. And then synchronizing capability is very good in AMI and Manchester. So this is for today's lecture. So we have seen about the line codes and why we need line codes, and what are the types of line codes and its example, and also comparison between the line codes. Okay, thank you.